Hello! Welcome to a topic that I've been wanting to do for over 2 years, yet kept postponing because, oh boy, it is a big one. So instead of trying to make the one big video to rule them all, we are just going to dip our toe in the water. Introduce the concept, and perhaps come back with more videos over time because this topic certainly warrants it. We are talking chemicals in clothing and some of the impacts that can have on people like you and me, as well as the environment and wildlife of our precious planet. I don't like making sweeping generalizations as a rule, but I do feel pretty comfortable making this one. There are lots of chemicals in your clothes. Even something as seemingly innocuous as a plain cotton t-shirt has often been treated with a host of different chemicals, even though the tag reads 100% cotton. How does that work? Bear in mind that the fashion industry plays things famously close to the chest, so it is incredibly hard to actually get reliable data on these things. But say you have a cotton t-shirt. What might it have gotten exposed to before you held it in your hands? Well, if it is cotton, we would first have to grow said cotton. And cotton is a famously thirsty plant, especially at the rates we have come to consume it. The growing of cotton has been linked to the drying out of the Aral Sea in Central Asia, now sporting 25,000 miles of largely exposed seabed instead of the inland lake that had been there for thousands of years. Just think about that for a moment. Our current system of production and consumption is quite literally drying out whole inland seas, not to mention draining the Ogallala Aquifer that fuels a significant part of US agriculture. And of course, unless the cotton grown is part of the less than 2% of cotton that is grown organically, we will be applying some sort of pesticide. The most common of which do not really break down properly in nature, but rather accumulates in wildlife and people alike over time. And that is to say nothing about the people who work with applying these pesticides to the crops directly. It is estimated that some 200,000 human beings die each year from acute pesticide poisoning, not just in the cotton industry. But to try to calculate those who suffer ill health or death due to chronic exposure over time is a lot more difficult. Not to mention that the cotton growing industry, much like chocolate, struggle with significant amounts of child labor. Once the cotton ripens, it must be harvested, either by hand or by machine, and the cotton ball separated from the seed in a process known as ginning. From what I can tell, these processes are largely mechanical, with the main hazards faced by the workers being noise and dust from the machinery. The cotton is then prepared, carded, combed, and spun, which, again, largely mechanical processes, if dusty and energy-consuming. The next chemical after our pesticides usually come into play when the cotton thread or fabric is bleached, either to achieve a whiter, more uniform look or to prepare the cloth for dyeing. Gone are the days of soaking cloth in wood ash and letting it bleach outside for several days in the sun, historically known as grassing. Instead, the cotton industry uses large amounts of chemicals like hydrogen peroxide, sodium chloride, and sodium hypochlorite. Chemicals that, for the most part, get washed out of the fabric before it reaches you or another end consumer, but are still used in such quantities and at such scale that they are still a big challenge to the wastewater and waterways that the treatment factories are connected to. Next up, dyeing. Pre-treatments before dyeing, mordants, dyes of all kinds. Most of the time, not even the individual dye houses know exactly what they are coloring our clothes with. The chemical companies that sell them the mixtures prefer to keep the exact contents and proportions a secret, which also puts the workers at additional risks since they are not being told what they should protect themselves from or why. And the more saturated the color, the more chemicals need to be used. The only thing a clothing company may request is that the dyes do not contain certain chemicals. And even then, they need to maintain a working relationship with a specific dye house over several years, not just shop around between every batch to save a cent or two per item, which the cheapest and most fast fashiony among them are wont to do. Plus regular testing, since the dye house could swap supplier mid-production or the chemical company may switch out their recipe for whichever reason, none of which are logged, reported, or tracked to go with the final garment or batch of garments. Because industrial secrets have been so good for our planet thus far. This is a huge challenge, and it follows the same pattern of behavior that I see every time I try to do a deep dive into any textile chemistry topic so far. Even the best accreditation we have for textiles today, such as Bluesign, GOTS, and oeko-tex, are labs and companies that can only exist by continuing their working relationship with the textile companies. And while that does introduce some predictable conflict of interest, they are the best we have at the moment. The main issue with all the textile accreditation systems is, as usual, one about money. You cannot test for the thousands of chemicals in industrial use today. That would be both prohibitively expensive and incredibly time-consuming. So instead, the accreditation labs test for a certain number of chemicals in each category. This may include chemicals that are or have gotten a significant amount of media attention in the past, or chemicals that have enough research behind them that we know for sure that they are problematic. Think heavy metals like cadmium or lead, or perfluorinated compounds like PFOS and PFOA. The issue with this is that it creates an illusion of safety to the average consumer. Just because a shirt doesn't include lead, that does not mean that it couldn't contain arsenic or chromium. And just because PFOS is missing from a raincoat, that does not mean it does not contain other perfluorinated compounds unless they are clearly stating so. What I'm trying to say is that even the best accreditation systems we have still have loopholes. So companies keen on keeping their accreditation labels will let their producers know that the products should not contain a specific list of chemicals, and those are the chemicals the accreditation labs test for, typically. And if a batch of clothing fails their chemical assessment, well, the financial burdens falls entirely on the shoulders of the garment factory, and neither on the chemical supplier nor the brand ordering the clothes in the first place. But this system does leave an awful lot of chemicals that the factories and their chemical suppliers can include in their dye and treatment mixtures. Bear in mind that even if a chemical starts showing up in nature, gets linked to hormone disruption or some other adverse effects, and slowly starts showing up on the do not use lists, the industry still needs a replacement chemical that performs many of the same roles that the now banned or side-eyed chemical did. They did not originally add it just for funsies, after all. And if the replacement chemical has similar physical and chemical properties that allowed it to replace the banned original, well, it may just turn out that the new, hitherto untested chemical turns out to be just as bad or worse than the chemical it replaced. We have several stories regarding this, well documented in research literature. When bisphenol A, also known as BPA, turned out to be healthfully unfortunate in both commercial plastics, baby foods, and as the thermoactive coating in many receipts, just to mention a few, several industry actors turned to bisphenol S instead. A chemical that, because it hadn't been picked up by massive scale industry actors yet, did not have the research behind it yet to determine whether it was safe or not. Happy days! Now the industry could write BPA free on their packaging and get a leg up on their competitors. Except it turned out that bisphenol S was potentially even worse for both people and the environment, and now wildlife and researchers have to contend with two potentially challenging chemicals instead of just the one. And some spot testing showed that the new products weren't necessarily entirely free of traces of BPA either, even when they claimed to be. So again, these textile accreditation systems are not inherently bad. They are some of the best we have available to us at the moment. But because time and money are of the essence to any business, there are some pitfalls that it is important to be aware of. I feel like I will say this on every single video I make about chemicals, but a lack of data does not a safer alternative make. It just means that we do not know the effects yet. And with an estimated 40 to 60,000 industrial chemicals in commerce globally, with more being developed every year, progress is just far too fast for toxicology and environmental assessments to keep up. Even if we reduce that number to the about 6,000 chemicals that account for approximately 90% of the total volume of industrial chemicals, that is still a lot of chemicals to commit significant resources to estimate the safety and longevity in nature of. Keep in mind also that the chemicals we have more extensive health information around, that this knowledge is pretty much always written in blood. The frontliners in these cases were very often factory workers who produced or used large quantities of the chemicals in question and suffered chronic condition or death because of it. This also means that a lot of our exposure information and limits of exposure are largely based on people being exposed to larger concentration over a period of time. So when people are exposed to very low amounts of many different chemicals over years and decades instead, insurance companies and even health providers may look at the exposure data and say that they are too low for the chemicals to have had the effect the patient is complaining about. Because the literature on the matter and the exposure limits are mostly set based on single chemical exposure in otherwise relatively clean environments, a far cry from the incredibly complex myriad of chemicals we are exposed to day in our modern world. I've talked about how mixtures of chemicals at low concentrations, even far below the limit of exposure set based on historical data, can still have a detrimental effect on you and me in a different video called the cocktail effect. I'll leave links somewhere if you want to know more about that. For now, though, suffice to say that because a minority of us actually work in chemical factories these days, most of us are exposed to a host of different chemicals at very, very low concentrations throughout our daily lives. Chemicals in our clothing is one, but also things like fire retardants in household textiles like couches and curtains, BPA or BPS in receipts we already talked about, plasticizers and UV-resistant chemicals in a lot of plastics to keep them going longer, and non-stick and water-repellent coatings inside canned food and containers, just to mention a few of the things we can get exposed to day to day. This collection of chemicals, or cocktail, works differently than if we were exposed to a higher amount of a single chemical in a controlled environment. But we have precious little data available on this because that kind of multi-chemical exposure experiment get really extensive, not to mention expensive, really, really fast. Put it all together and you end up with a system of professionals at risk of accidentally or unwittingly gaslighting their client because the studies we so rely on as academics, and because they are the best we have at present, are still very different from lab or factory conditions to most people's complex daily lives and exposure patterns. Most of the time, people reacting to their clothing find the finger pointed back towards themselves when they try to voice their concern, with an industry go-to deflection being that this is just a small number of people being overly sensitive when they may very well be acting as canaries in the coal mine for all of us. Can we fingerprint people based on their unique exposure patterns? Now, that would be an interesting thing to investigate, but I digress. Also, don't forget that research is a money game these days. How many scientific publications can we generate with this limited amount of funding? And because the number of publications is one of the biggest metrics an academic is judged on, whoever publishes the most also gets more credibility and usually more funding, which allows them to publish even more, which allows for more funding, and so on and so forth. Meaning that Really big or really extensive studies may get passed over in favor of smaller studies the academic or research group can actually afford to fund right now, with the exception of some government-funded continuous observation studies where data and articles get published as the researchers learn more over time. But back to our t-shirt. As you may have figured out by now, the pre-treatment and dyeing of our cloth is for most businesses simply a black box, including for the workers who are often elbow deep in dyeing vats and with enormous variability from factory to factory when it comes to what sort of personal protection equipment they are issued with, if any. We do not get to know exactly which chemicals go into coloring our garments. So if you, for instance, are allergic to a specific black or purple dye, but they are your favorite colors, well, you might just be tough out of luck, or constrain your purchases to businesses with solid return policies. And yes, people can be allergic to the dyes or other chemicals in their clothes. Even formaldehyde, which, yes, the formaldehyde of the weird science people in movies where they have a lot of, samples lining the walls in suspicious glass jars, that formaldehyde is often used to create wrinkle-resistant clothing. And that too can absolutely be an allergen. And allergies can worsen with each exposure, so even if you are allergic and you return an item of clothing after having had a reaction to it, you may still grow sicker every time and get a more violent reaction every time you try to find a piece of clothing that you don't react to. Or, since a lot of these chemicals may also sort of get up and off gas into the air around the clothing when we are wearing it, if a colleague or fellow commuter has clothes coated with formaldehyde close to you, well, we can't control every consumer everywhere. That would be insane. So the people with allergies just suffer or avoid people in general. And if you are really unlucky, you may develop full-blown multiple chemical sensitivity or mast cell activation syndrome, a fairly freshly understood but incredibly debilitating condition where your protective mast cells go into overdrive and a person may seem like they are suddenly allergic to almost everything. But because this aforementioned black box of a process is considered a part of the manufacturing process rather than an ingredient, for some reason, we do not get a single hint as to what we put next to our skin on the garment tag of our clothing. And if you thought this was the worst of it, we still have a ways to go before the t-shirt ends up in yours or other people's hands. The next processes can happen somewhat interchangeably, but if the fabric has an all-over print, this may be the next step, onto the printing press. If you ever wondered why garments or products labeled oeko-tex or blue sign may feature fewer printed items than their unlabeled counterparts, it may be because it is harder to pass the safe chemical tests with printed garments or textiles. Printing is just difficult to do at fast fashion scale in a way that complies with even the somewhat loophole-inclined best practice chemical safety labels out there. A reminder of this popped up in 2008 when parents of several hundred infants noticed that their children were developing significant rashes on their backs corresponding to the garment's tagless heat transfer garment tags. And infant and toddler clothes are regulated far stricter than adult clothing, which often has no regulation whatsoever, and this still passed the checkpoints. But Say you get the printing out of the way. For a simple cotton t-shirt, the next step may be cutting and stitching said garment together, something that is often done with polyester thread, again, even if the garment tag reads 100% cotton. This also explains why, if you've ever tried to over-dye something at home, you may have been frustrated to learn that the body of your garment took on the dye as expected, but you now have a very visible accidental contrast stitching because the sewing thread didn't take the dye at all. Chemically, polyester and other synthetic fibers are very different to natural fibers, so the way they dye, and not to mention which dyes they take color from, are fundamentally different. Thought we were done yet? Alas, even at this stage, our shirty cotton friend may yet be subjected to ever more chemicals. Before packaging and shipping, finished garments may be treated with so-called soft touch chemicals, whose only purpose is for the garment to feel soft as you touch it in the shop, and that will wash out after a couple of rounds in your washing machine. But now, at long last, may our t-shirt friend be packaged safely in ever more new plastic that may off-gas other new and fun chemicals to that which it is wrapping, and shipped halfway across the globe to make its way to a retailer near you, ready to provide a lungful of mixed chemicals to especially the frontline workers who are either dyeing, sewing, packaging, or unpackaging these clothes suddenly so available to us all over the world. A cotton t-shirt is not even the most egregious example I could think of. At least for a t-shirt, you may argue that the polyester thread is such a small percent of the whole that they barely warrant mentioning, though I would tend to disagree. But several months ago, I received an email from a viewer, I think, after they had watched my video on superwash treatment of wool, and they told me that they got rashes from many synthetic textiles and natural synthetic blends. They had made the switch to merino wool small clothes in a bid to try to find garments that they wouldn't break out from, and indeed, they didn't break out into rashes from the merino wool part themselves. But along the top of their new pairs of underwear, even though the tag still reads 100% merino wool, was a very much not merino wool elastic. And that was causing our poor friend to break out into a very recognizable rash exactly where the elastic sat against their skin. And with underwear, you really cannot make the argument that the elastic is such a small percent of the whole that it doesn't warrant mentioning. I haven't checked against my own small clothes, but I would venture a guess that the elastic makes up at least 3 to 5% of the whole. Something that decidedly should have made its way onto the tag, if the clothes industry was regulated in any way, shape, or form like our food or cosmetics industries, which it still frustrates me that they aren't. And that brings us neatly to the last part. What can you and I, as small consumers, do about this mess? I think the first and potentially most revolutionary step we can take is to make sure we are wearing our critical thinking hat when we think and learn about the complex web of consumers and businesses to businesses interdependence on each other. Whom does it impact and who does it benefit? How does the business make money and pay their rent? What systems of government or oppression are they dependent on to continue business as usual? I often get asked what the solution to X, Y, or Z problem is on videos like these, and why I do not provide a simple one-size-fits-all solution at the end of each video so that people know exactly what to do in each instance. And honestly, a big part of that is that these problems are so big and so intertwined that the solution cannot be just to do this one simple thing. These problems are massive, complex, and dynamic, and so our solutions need to adapt and address many different challenges at many different levels as well. That, and I do not just want to give you a laundry list of things you can do. I want you to think, and think hard. Read books, ask questions, write things out and try to analyze them. Where are the loopholes? Many companies continue to do questionable things simply because they have managed to build a consumer mindset where we are encouraged to consume both content, and items, and then go to work to earn more money, to consume ever more content and items, and keep the ball rolling. Gotta keep that economy running, am I right? So the biggest thing I think we can all do is to be a little more critical of the content we consume. What is this story not telling us? Is this designed to make me angry? Anger and outrage are often some of the easiest things to trigger in people, and it makes us want to act instantly and often rashly. Step back, breathe, and think about who this angle of the story benefits. And if that makes you disagree with me or some of my discussion points, all the better. This community has shown time and time again that they are incredibly clever and have in-depth knowledge about a whole host of things, and I couldn't possibly be an expert in even half of it. So keep it up. That being said, if you heard all that and still want a few bullet points to get you started, here are a few things to keep in mind. Wear your clothes for longer. Mend them when they wear out if you can and have the time. I know this is old news to many of you, but I didn't grow up with it, so here goes. Cultivate an at-home or lounge wardrobe and save the more dressy outfits for going to work, school, or going out. Right now I am wearing a heavily mended pair of old sweatpants, complete with paint stains, because wearing this at home allows me to save my nicer clothes, allowing them to stay nice for longer, before they might later become worn to a point where they too become loungewear. It helps to be a gremlin who refuses to wear anything but comfy clothes anyway. When you must buy new, try to look for second-hand options or buy nothing or clothes swapping groups if you can. And again, if you have the time, I know time is often a very scarce resource for a lot of people, so don't feel bad if you can't do all these things. But if or when you do need to source items new, try to avoid the ultra fast fashion brands that launch new clothes every single day, or knockoffs or fakes of bigger brand names along the street, which are usually subject to less oversight and more unfortunate chemicals. Also, trust your nose. We are encouraged to check if our food has gone bad by looking at and smelling it, but somehow not our clothes. If it smells chemically or the store is suspiciously perfumed, perhaps give it a pass. You can also look for the accreditation labels I mentioned earlier. Blue Sign, oeko-tex, GOTS, A-Firm, ZDHC, to name some of the biggest ones. Despite the issues I mentioned earlier in this video, I have to reiterate that they are still some of the best we have available to us at the moment. So don't demonize them for having to stay in business. The same with fashion and fast fashion brands. You can check online if they have published a restricted substances list or other commitments to reduce and eliminate their use of hazardous chemicals. Just again, be wary of woolly phrasing. Don that critical thinking hat and treat the fashion brands as you would treat encountering a fae in the woods. They may not be allowed to lie outright, but they absolutely will lie with the truth, and how they choose to phrase the truth all the same. Tread with caution. And wash your new clothes before you wear them. Trust me. We'll get back to this in a later video, but for now, try to avoid performance textile when you can. These are textiles or clothing that profess additional qualities in addition to being clothes. Things like stain resistance, wrinkle resistance, water repellency, fire retardant, odor resistant, sweat wicking, you know, all those sort of buzzwords. Additional features are going to mean additional chemical treatments, both for synthetics, synthetic natural blends, and even entirely natural fabrics. There are wools out there where the description brags about their stain and water repellency, if not just outright writing that they are Teflon coated, as a good thing. So, you know, read the description and you'll be surprised at the amount of stuff you find just out there. In addition, and especially if you have sensitive skin or have broken out in hives from clothing before, perhaps try to avoid really bright, saturated and neon colors or clothes that have extensive prints all over, especially on synthetics like polyester. The dyes and finishes on a garment, even synthetics, are worse than the synthetics themselves when it comes to toxic chemicals, so perhaps keep that in mind. The last thing I wish for is for us as a whole to just stop accepting companies being allowed to have industrial secrets when it comes to chemicals. Why is it that as an analytical chemist, I would have to source or perhaps even synthesize, which analytical chemists have had to do in the past, the chemical standards we need to analyze the chemicals in a sample that industry actors have already used and are using in massive scale? Why can't the industry that produces or uses the chemicals just be required to provide me a sample of the chemicals they use upon request? Why do we have to play this ever-changing cat and mouse game between researching the effects, getting chemicals on a watch list, but then having to figure out what the industry is replacing the old chemicals with? Why? And why are clothes companies allowed to not list any of the treatments during the manufacturing process on their garment tags? Can't we just require them to list everything the clothing has been subjected to, same as cosmetics companies have to list all the ingredients in their soaps and creams? If I could have just one of these whys, it would be to make fashion brands have to list all the treatments on their garment tags. Every single dye, mordant, soft touch treatments, and all the other treatments. That way, at least us, the consumer, would be able to make a slightly more informed choice than we are currently able to do. I don't know how we would put enough pressure on companies and legislators to make that happen, though, so if you have any good ideas for our global community, please do let us know. This one goes to all of you who continuously on my more sciencey videos keep saying that you would listen to many more minutes of me going on and on about the ranting of the current state of affairs for textiles and stuff. I hope you are satisfied. Also, if you wish to widen your reading scope with some more non-fiction excellency, I can recommend To Die For, written by Alden Wicker, which both inspired and made this video possible in the first place because, again, there aren't a lot of references to try to write and inform about these things. And of course, To Die For features an extensive reference list in the back if you are still not satisfied and want more, as does this video, with the usual list of references referred to throughout the video listed easily accessible in the description box below for your perusal. Thank you so much for watching, especially if you made it all the way here to the end. Thank you also to our dear patrons who help me keep the lights on and keep our furry voids amply supplied with snacks. If you want more videos like these and maybe even have a few coins to spare, perhaps go check it out. I really cannot do this without your support, so thank you again. Bye!
Ooh. That's it, I'm not going.